Hello everyone. So today we are going to see about a new design pattern, that is builder design pattern. So first, before moving to what the design pattern is, first we need to check under which category this comes. So I have already told there are three categories in design pattern. One is creational, one is behavioral, and one is structural. So this is which comes under which category. So builder, as you, I think you have guessed what, and it will come under which category because as the name suggests, it's builder. It tries to build the object, so it's a creational design pattern. Okay, so this builder design pattern is a creational design pattern. So we will see what is the, so when we need to use and in what scenario we need to use this type of builder design pattern. Okay, so this is used like when we want to create objects which are having many steps, and those are same steps in creation but the implementation is different in each of the product. So while creating the object we may have many steps to be followed, so we need to create each of the part of the object. But if we have two or three classes, and while creating, so we may have four or five steps need to be followed on for all these classes, but it can be different in each class. So let me give an example. So we have desktop, and under desktop we may have HP desktop and Dell desktop. Okay, so these two, this is base class and these are derived class. Okay, so here I will create this desktop as interface and these are concrete. Okay, so these are concrete classes. So if you see, desktop will have we need to create like we need to build monitor, then we need to build a RAM, then we need to build keyboard. So we will have certain steps to be followed. So these are many steps, not a single step. So these are many steps, and irrespective of HP or Dell we need to follow all the same, but the implementation for each object will be different. So if we are having Dell desktop means its RAM may be different. It can be 8 or 16. If we take HP, it can be different. And if we take monitor, HP can use some other monitor, uh, and Dell can do some other monitor. And keyboard, similarly, keyboard. HP will buy the keyboard from some other vendor, and Dell will buy some other vendor. So we need to create object with same step, but the configuration will be different. So here I can mention another object, configuration. Configuration is different for each type of object, and it is huge configuration, and it is different for each type of object. Okay, so this is the first point. When we want to create objects which are having many steps, or which or many steps or many configurations in the creation of the object, but the implementation is different in each type. So configuration can be different in each object. So this is the first problem. If we encounter this problem, then we can use builder design pattern. Okay, and as I already told, when the creation have very complex creation process, when the objects have very complex creation process, so the complex creation process is nothing but, if we create an object it's not complete. So if we create an object for desktop, this HDA desktop, it's not complete. So we need to build monitor, RAM, keyboard. So this desktop will have many like many member variables like number of keys in keyboard and monitor size, everything. Like for each part, it will have many member variables. So each need to be populated during the object creation. If it is not populated, then it is incomplete. So if we, how can we check if it is like object is complex, its creation is complex or not? So simply we can say if a constructor has too many or parameters. So if the constructor has too many parameters, then it is a complex. So if constructor has too many parameters, then we can say the creation process is complex. Okay, so we can say this way also. So if you have too many parameters in constructors, then also we can say the construction process is complex. So we can create like a constructor with many parameters, but we should not write a complex logic or a big constructor or constructor is accepting many parameters. So we should not write a constructor that way. It is not a good practice. So what we need to do is we need to segregate that constructor into different functions, and we need to write it as a different function. So that's what I have mentioned here, build monitor. So we can segregate that constructor into build monitor, build RAM, build keyboard. Like that we can segregate and we can create separate functions. So that is, so this is the problem statement for build design pattern. So if we have many steps to be followed and the object creation is very complex and configuration is different for each type of object, then we can use this builder pattern. Okay, so this build monitor, build RAM, build keyboard. So okay, so these uh, functions can be written inside this HP desktop or Dell desktop itself. It can be written and we can use it, but usually uh, if we are creating, if we are designing a class, how it should be designed is it should have member functions which represents its behavior, only its behavior, not how it is created or how uh, we are creating. So if we write this function like build monitor, then if by looking at the desktop, if we are writing this function as member function say desktop class, then we may think the desktop class is responsible for building a monitor. It's not that. So it's not its behavior, it's part of the object creation. So that's why we are segregating this and we need to create a different class like builder class. So that's how we need to do. So that's the idea of this builder design pattern. So what we are going to do is we are going to create two interfaces. So if you see, I have this product. I'm going to create an interface for that product, and it will have the member functions like its behaviors: do task 1, do task 2, do task 3, and we can have multiple classes derived from this interface like product A, product B, product C. And I am going to create a builder interface. So this builder interface is responsible for building this objects, whatever objects I have mentioned above. So we are going to create an interface and it is responsible for. So if we have a desktop product means we need to create this builder functions as build monitor, build keyboard and build RAM. Like that I need to build CPU, like that we need to it. But I have I have taken product as a generic example. So I am writing this build top, build mid, build bottom. So these are like part of, we can consider top, mid, bottom or part of the object. Okay, so this is an interface and we will have these virtual functions declared inside it, and we are going to build a class for each of the products which we have created above. Okay, so this builder will have its own implementation of build top, build mid, build bottom for each of this product. So if it is product A means top can be, we can configure different top, we can configure different mid from apart from B and C. So that's why we are creating different classes and it should have its own implementation of these virtual functions. Okay, and finally we are going to write a director class. So this director class is responsible for getting the product and calling all these functions and returning it. So basically in this builder design pattern, how we are going to do is we are going to have a product interface, builder interface and builder director. So this builder directory is responsible for calling all the building functions of the object and to return it. So I will show a code example for this. I already wrote the code. So we are having an interface for product is having do function. It is the behavior of the object, okay, or behavior of that class. So I'm going to create prod A and prod B, which is derived from this iProduct interface. So it will have its own implementation of do. Okay, so I'm just printing a statement prod A do, prod B do like that, and I am going to create an interface for builder. So this builder will have functions build top, build mid, build bottom like that. And it is having a member variable product inside it. And that is protected. So whichever we are going to create build a class for each of the product we have created above. So I'm going to create prod A builder, prod B builder, which is inherited from the builder interface. Okay, and it will have its own implementation of build top, mid, bottom like that. And in constructor I'm going to create an object prod A object and I'm going to assign it to this variable inside the interface. So similarly, I have created prod B builder, which is inherited from prod builder interface, and it will have its own implementation of build top, build mid, build bottom. And inside constructor, I have created, actually it should be prod B. Okay, I have done some mistake. So it is creating its respective product. And finally, I am creating a director class, which is responsible for calling all these functions. And I'm getting get product a function in the interface which will return the actual object. So inside main I am just creating the builder, like interface type is of iProd builder and the type is whatever the product we need, respective product prod A, prod B, like that we need to create an object. And I'm going to create a director and this director is responsible for building the desktop. So when I call the build desktop, it will build all the parts of the object, and by calling the get product, I will get the actual product which is completely built. So using this, I am uh, calling the member functions of that object. So this is about builder design pattern. So builder design pattern is nothing but if you have complex creation process and many configurations involved, then we are segregating that creation process to a separate class and we are naming that class as builder class. So in client code, what we are doing is we are just creating a builder class and the builder class is responsible for creating the actual object, and we are creating director and this director is responsible for building each part of the object and returning the complete object. So this is about uh, build a design pattern, guys. I hope you have understood. Thank you.